let's look at fractional indices. And in the corner here are the rules of logarithms, or the laws of logarithms. You should remember them. Alright. Now, what happened? We're looking at what happens when a number is raised to a fraction. So the index is a fraction. Alright, suppose you have this equation to solve. You raise 2 to the power of x is equal to 4. You should find the value of x. What is x equal to? Alright, let's see. We're going to find x. What you can say here is 2 to the power of x equals 2 to the power of something else, or 2 to the power of something, I should say. So 2 to the power of x is equal to 2 to the power of 2, because 2 to the power of 2 gives you 4. Alright? Now, if 2 to the x is equal to 2 to the 2, is it possible that x could be 3? If that is so, you would be saying 2 to the 3 is equal to 2 to the 2. No, that couldn't work. 2 to the 3 cannot be equal to 2 to the 2. Could it be that x is 1? You'd just say 2 to the 1 is equal to 2 to the 2. No, that couldn't work. They would be different. 2 to the 1 is different from 2 to the 2. Could it be that 2 to the 2 is equal to 2 to the 2? Well, of course, 2 squared is equal to 2 squared. Alright. Oh, so guess what? What this means is x has to be 2. Right? X has to be 2 in order for this to work, because 2 is 2. So x must be 2. Alright, so now we got it. So, in this case, x would have to be equal to 2. Alright, so you solve the equation, x is 2. Good. Now, let's look at something else. I have 4 to the x equals 2. Good. What is x? Well, now, we know that 4 is equal to 2 squared, right? So let's rewrite the 4 as 2 squared. 2 squared. And then it's to the x. So let's put it in bracket and raise to the power of x is equal to 2. Alright. Fair enough. Now what is 2 squared? 2 to the 2 and then to the x. According to the power rule, the power law of indices, x to the a and that raised to the b is x to the, multiply the indices, a times b. So 2 to the 2 and that raised to the x is equal to, multiply the indices, 2 by x. So it's 2 to the 2x equals 2. Okay, good. But 2 is the same as 2 to the 1. Now, if you have 2 to the 2x equal 2 to the 1, could it be that 2x is different from 1? That couldn't be. If you're going to raise 2 to this index and 2 to the 1 and they are equal, then this index must be equal to 1. So let's drop off the 2 and just concentrate on the 2x and the 1. Alright? So you can see that 2x must be equal to 1. Alright? You can see that these things must be equal. You cannot have 2 to a number equal 2 to a different number. Can't. The numbers that you raise them to must be the same thing. So 2x must be equal to 1. Alright. Now what is x? If you divide the left by 2 and the right by 2, 2 cancel 2, so you have x equal half. So what you're saying is that 4 to the power of a half is equal to 2. Alright? 4 to the half is equal to 2. Let's write that down here. 4 to the half is equal to 2. Now, let's look at another example. If we have, say, 3 to the x equals 9, then we can see here that 3 to the x equal, we can rewrite the 9 as 3 to something. It's 3 squared. Okay, good. So x is equal to 2. From our previous argument, x must be equal to 2, because you cannot have 3 to the 4 equal 3 to the 2. No, it's not equal. 3 to the 3 is not equal to 3 to the 2. Try 1. 3 to the 1 is not equal to 3 to the 2. Only 3 to the 2 is equal to 3 to the 2. So if 3 to the 2 is equal to 3 to the 2, then the x must be 2. So x equals 2. Good. We solve this equation. Now, let's do it this way now. 9 to the x equals 3. What is x equal to? Alright, let's rewrite 9 as 3 to the 3. 3 to the 2, because we know 3 squared is 9. So 3 squared is 9. So we write that, and then it's 9 to the x. So it's 3 squared to the x equals 3. Now, we have to multiply the indices according to this here. X to the a and that to the b is x to the a times b. So 3 to the 2 to the x, all of that to the x means 3 to the 2 times x. So 3 to the 2x is equal to 3. But 3 is the same as 3 to the 1. Now, based on our previous argument, you cannot have 3 to a number equal to 3 to a different number. It must be 3 to a number equal 3 to the same number. So 2x and 1 are the same number. So 2x equals 1. If you divide both sides now by 2, divide by 2, divide by 2, what you get is x equal a half. So therefore, x is a half. Alright? It's this one. We finished with this long time. It's this one you're looking at. This x is half. So 9 to the power of half equals 3. Let's look at one more. Suppose we have, let's say, we have 4 to the x equals 16. 4 to the x is 16. Then we can write it as 4 to the 4. No, 4 to the x equal 4 squared. So in this case, x would be 2. So x equals 2. Now, if we have 16 to the x equals 4, this can be written as 4 squared, which is 16, to the x equals 4. So, and it's 4 to the 1. So, 2x equals 1. So x would be half. So therefore, x is, we finish with this. In this case, x is half. So 16 to the half is equal to 4. Alright. Do you see anything? Any pattern from what you know previously? Hold on. We know that the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. Hold on. Suppose we try 25. Let's try 25 and see what would happen. Interesting. Suppose we say 5 to the x is equal to 25. If we rewrite 25 as 5 squared, we would have 5 to the x is equal to 5 squared. Good. So x is 2. That's nice. Suppose now we say if 25 to the x is equal to 5, we rewrite 25 as 5 squared and we say this is 5 squared to the x is equal to 5. But 5 to the 2 to the x means we must multiply 2 by x, and 5 means 5 to the 1. Now 2x equals 1. When we transpose for x, x equals a half. So therefore 25 to the x, which is 25 to the half, equals 5. 25, x is half, so 25 to the half equals 5. But the square root of 25 is 5. Well, no. This seems to be saying that x raised to the power of, a number x raised to the power of a half means the same as the square root of x. A number to the half means the square root of x. Let's try something here. Suppose we have, what's it? We have 3 to the x. Let's change the number now. 3 to the a is equal to 27. We know that 3 is 9, 9 3 is 27. So 3 to the a is equal to 3 cubed. 3 cubed is 27. So a is 3. No problem. Now suppose we say 27 to the a is equal to 3. 27 is the same as 3 cubed. So 3 cubed to the a is equal to 3. And then 3 is the same as 3 to the 1. If we look at the powers, the indices here, we have to multiply 3 by a. So it's 3 to the 3a is equal to 3 to the 1. But at the same time, we see that 3a is equal to 1. If 3a is equal to 1, then a is 1/3. Now, if a is 1/3, we're saying that 27 to the 1/3, 27 to the 1/3 is equal to 3. But we looked earlier and saw that 3 is the cube root of 27. So could it be that, first of all, 3 is the cube root of 27. So this is implying that 27 to the power of 1/3 is the cube root of 27. Could it be that x raised to the 1/3 is equal to the cube root of x? And could it be that if we try with other numbers, we would see that x raised to the 1/a is equal to the a root of x? Well, it is, right? So when you raise a number to a fraction, to 1 over something, right? Raise a number to the 1 over a. What you're getting is the a root of that number. If we change the a to n, it's a bit more comfortable saying n and nth root. So if we have a number x raised to the power of 1 over n, what we're looking at is the nth root of x. Let me rewrite that part a bit better. I need to make an adjustment to the, so that the hook here is a bit wider for the n. Alright, so x raised to the 1 over n is the same as the nth root of x. So that always applies. Alright, so let's erase these other things that we have here and write down that particular result. Very important for you to remember. If you have a number x raised to the power of, well, let's write it below here. Good. We can write it in white too. If we have a number, that number is x, whatever x is, and it's raised to the power of 1 over n. What we get is the same thing as the nth root of x. So there is yet another result, and it has to do with fractional index when you raise a number to a fraction.